So we're going to solve rational equations today. So we're going to solve for x. Now, my favorite, well, first of all, let's look at what we've got here. Okay, we've got a 4, we've got an x minus 2. Since it's a fraction and we've got this subtraction here, I'm going to go ahead and put this in parentheses to keep in mind that the 4 and the 2 cannot cancel. It's not just a 2, it's an x minus 2. Over here, we've got our x minus 1, putting that in parentheses on top, and x minus 2, putting it in parentheses on the bottom. Now, since most people do not like fractions, what's nice about having an equation is if you want to make the x minus 2 down here go away on the left side, whatever you do to make that happen, you can do it to the other side also. And don't get this confused when you're adding or subtracting fractions, all right? If you're just adding or subtracting fractions, you have to make the denominators the same. Or multiplying, you still, have to work with it. But once it becomes an equation, we can actually get rid of the fractions, which tends to make people happy. Here's how you do it. All right, now we've got our wall here because it's an equal sign. If I want to make this x minus 2, this thing in parentheses, go away, since it's being divided, I could multiply this side by an x minus 2. Because really, it's like x minus 2 over 1, so it will cancel out. I can do that on the left as long as I come over here to the right side and multiply everything on the right by x minus 2. Keeping in mind that that's really on the top. I'm writing it a pi because it's really over 1. What happens when we do that right there, this x minus 2 cancels with that x minus 2, and that on the right side, x minus 2 cancels that one. Okay, if it helps, if you have trouble seeing that, the x minus 2 on the right canceled that one, x minus 2 on the left canceled that one. All right, so what you would end up having left is, on the left side, all we have is 4 over 1, which is 4. On the right side, all we have is the x minus 1 over 1, which is just x minus 1. Now we're going to solve for x. To solve for x, we're going to get rid of this 1 being subtracted, so we're going to add 1 to both sides, and we'll find that 5 is equal to x. Now, I know how you guys are, but you should go over and you should do a check. You go back to your original, and you take that 5 and you plug it in. So if we take that 5 and plug it in everywhere you see an x, we're going to see if it comes out to be the same. So on the left side, we have 4 over 3, because 5 minus 2 is 3. On the right side, 5 minus 1 is 4, and 5 minus 2 is 3, so it checks out. So that is definitely our answer, x equals 5. On number 2, all right, so we got 3 different numbers down here, okay? Some people will tell you, hey, just multiply it all by the GCF and different things. I'm going to show you a little bit different way to do it, all right? We're going to do it like one step at a time. But since I have some addition and subtraction inside my fractions, I'm going to put those 2 in parentheses. All right, so here's what I'm going to do. I have this 6 on the bottom, okay? I want to get rid of the 6 on the bottom so I don't have a fraction. So to do that, I would have to multiply by 6. What you have to realize is if I'm going to multiply this left side by 6, if I'm going to multiply this one part by 6, I have to multiply the whole left side by 6. And if I'm multiplying the left side by 6, I have to multiply the right side by 6. Okay, just taking you through. And then I'll show you how I do it a little bit shorter in just a second, just after I explain this. So if I'm multiplying the first fraction, what I'm actually doing here is I've got a 2a plus 1 in parentheses on top over 6. And over here I have an a over 2. And my original look like this. Okay, so now I'm multiplying the left side by 6. That means every term on the left side has to be multiplied by 6. So this first term gets multiplied by 6. It's just your property. And the second term gets multiplied by 6. And then that means if I did it on the left, I have to do it on the right. So the right side, forgot to put the parentheses. So the right side also gets multiplied by 6. These are really 6/1, so I'm putting them up high in the top part of the fraction. All right, so I multiplied every term on the left side by 6, and I multiplied every term on the right side by 6. Okay, a little shortcut version would just be to look and say, hey, I've got this 6 on the bottom. I want it to go away. So I'm going to multiply every term in the entire equation by 6. Once you do that, don't worry about the 2 and the 3 just yet. Once you do that, cancel out what can be canceled out. So for instance, this 6 cancels out that 6. In this fraction, you can divide 6 and 2. You can divide by 2, which leaves you a 3 up here. And this 6 and 3, you can divide by 3, and that leaves you a 2. Now, when we write what we have left, in the first fraction, the 6 is canceled. We have a 2a plus 11. We have our plus sign here. In this one, the denominator is gone. We're left with 3 times a on the top. Over here, the denominator is gone. We're left with 2 times that. I'll write it out first, and I'll do distributive property in just a second. So now we have no more fractions. On the left side, we can put 2a plus 3a and get 5a. And then we put those two together because they're like terms, and then put our plus 1 there. On the right side, we can do distributive property and get 2a minus 2. I'm going to go over here where I have a little more room so you can see what's happening. All right, that's where we are. So now we're going back to solving equations. We simplified both sides. Now we need to get the variable on one side only. So you're either going to subtract the 5a or subtract the 2a. I'm going to subtract the 2a from both sides. So we have 3a plus 1 equals this one away, leaving you a minus 2. Now we're going to get a by itself. So we're going to subtract the 1 because that's farther from the a. 3a equals negative 3. And then we're going to divide by the 3 to get rid of it since it was being multiplied. And we'll find that a equals negative 1. All right, so if we go to check that, go back to our original. And when we plug in a negative 1 for a, right there, and right there. 2 times negative 1 is a negative 2. Here we've got a negative 1 over 2. Negative 1 minus 1 is a negative 2. Negative 2 plus 1 is a negative 1. If I'm going to add these together, I need them to have the same denominator. So I'm going to multiply the bottom by 3, which means I have to multiply the top by 3. So the top will be a negative 3. The right side, there's nothing for me to do right now. On the left, since the denominators are the same, I'll keep it. Negative 1 plus negative 3 is negative 4. And negative 4 over 6 simplifies to negative 2/3, because if you divide top and bottom by 2, you get that. So it checks out. All right, now, someone else might ask, what if I multiplied by, instead of multiplying by a 6, what if I had multiplied by a 2 or 3? Okay, so I'm going to run through that with you. I'm going to erase what I've got here and run through that scenario with you real quick. Okay. All right, so if someone had done that, all right, if they had this over 6 and a over 2 equals a minus 1 over 3. Let's say that someone decided they wanted to get rid of the 2 first. Okay, so they would multiply each term by 2 all the way across the equation. So this is an alternative way to do the problem. Okay, and you're going to see why. I'll go back and explain why I chose the 6 and not the 2 or the 3 first. When you do this and you divide by 2 here, when you divide by 2 there, you still have a 3. So we still have this 3 on the bottom. Now these 2's canceled out, but that didn't cancel out at all. So now you'd have to go through this step again and get rid of the 3, and you would do that by multiplying each term by 3. So then the 3's would cancel there and here. So then you would end up with a 2a plus 1 plus 3 times a, and then distributive property over here. You'll still get 5a plus 1 equals 2a minus 2, which is what we have over there. Okay, you'll still get the same thing. So my recommendation, when you're trying to figure out which one do I start with, if you have a bunch of numbers there, start with the biggest number. Multiply by it first. Now, if these other 2 numbers don't go into 6, like if I had a 5 sitting over here, you'd have to go through this. You'd have to go through it again, kind of like we did from here. All right, but if you start with your biggest number, that's your best chance. If you can look at the bottom, the 6, the 2, and the 3, and if you know that the GCF is 6, then go with that. That will only take one step. If you actually use the GCF, it will only take you one step to get rid of the fractions. All right, so now the next problem is number 3. All right, I'm going to make a new video on that here in just a second. So I'm going to make a new video on number 3 and that other one.